Okay, we're going to take a look at physical and chemical properties and an introduction to physical and chemical changes. Get my pen ready. Chemists use properties to distinguish between substances and to separate them. To distinguish between substances, if something was boiling at 100 degrees Celsius, that could indicate to them that the substance was water. If it boiled at 120 degrees Celsius, then they know it would not be water because that's not the boiling point of water. Both physical and chemical properties can be extensive or intensive. Extensive properties depends on the amount. The amount of matter present is important. Your extensive properties are going to deal with numbers, the volume of something. For example, 25 milliliters. The mass, I have 5 grams of sand. The amount of energy, 2,221 joules of energy. Anytime you're giving the number value, you're looking at extensive properties. Intensive properties, these are not going to depend on the amount. Doesn't matter if you have a bunch or a little. Melting point, boiling point, density, the color of something, and if it's conducting electricity or not. Scientists can actually go through and determine if something's going to melt, and once they've determined that, then they can go back and say, okay, now I know the melting point, I know the boiling point, I know the density. Whether I have a bunch of it or a little bit, it's not going to change that property. It's intensive, so again, the amount does not matter. Okay, looking at physical properties, a characteristic that can be observed or measured without changing the identity of the substance. And that's important to point out that when you look at physical properties, these are measured or observed without changing the identity of the substance. Physical properties describe the substance rather than describing how it can change into other substances. So you're just doing a description at this point. Examples: it is able to melt. It is able to boil. We know the boiling point of water is 100 degrees Celsius. Freezing point of water is 0 degrees Celsius. We could say something has a red color, a strong sulfur odor, a 22.5 grams per centimeters cubed for a density. On the Mohs hardness scale, has a value of 8. A substance is able to dissolve in water, meaning it is a solubility. Those are physical properties. We can describe them without changing the identity. Physical change is a change in a substance that does not involve a change in the identity. It's going to look different, but again, the identity of that substance is still going to be the same. Grinding metal. If you grind metal up, now you just have smaller pieces of the metal. It's still that same metal. Cutting paper. If you cut a piece of paper, you still have paper, but it's going to be in smaller pieces. Melting. You could have frozen water, which is ice. It melts to liquid water, but it's still water. Boiling. You could have liquid water. It boils. It's now a water vapor. Again, you have not changed the identity, you've only changed its physical appearance. Chemical properties relates to a substance's ability to undergo changes that transform it into a different substance. So here we're looking at its ability to become something different. Charcoal, which is carbon, has the ability to combine with the oxygen in the air to burn. Iron has the ability to combine with oxygen in the air in order to rust. Silver can combine with sulfur in the air to cause it to tarnish. Chemical change, which is also known as a chemical reaction. A change in which one or more substances are converted into different substances, meaning something new is made. Any change in which substances are converted into different substances and cannot be changed back to the original. That new substance is going to have a whole new set of properties. The substances that react are known as our reactants. The new substance that's formed or produced is known as our product. Chemical reactions have just the general idea of A plus B. These are my reactants. They are going to combine together through a chemical change, chemical reaction, to produce C and D, which are going to be our products. An example, charcoal burning. We know that charcoal is just carbon. It's going to combine with oxygen, and it's going to produce carbon dioxide, which is going to be the product. The properties for this carbon dioxide are going to be different than the properties of carbon and oxygen. Note about chemical changes or chemical reactions. It is important to note that chemical changes do not affect the total amount of matter present before and after a reaction. The amount of matter, and therefore the total mass, remains the same. Total mass is going to remain the same. It's just now in different forms. Any change in which substances are converted into different substances and cannot be changed back to the original is known as a chemical change. So your chemical reaction, you have A plus B, that is going to yield C plus D. Notice that my product is completely different than the reactant. I've made something new. There are 5 signs that a chemical reaction has occurred, and you are responsible for knowing all 5 of them. Sometimes you'll have a scenario and it'll say, pull out the evidence that a chemical change has occurred. Hopefully we get back to labs later in the year, and you will actually do labs and you're going to look for signs of a chemical reaction. Any change in temperature, a change in the color, producing gas or bubbles, producing light, a formation of a precipitant, which is many times abbreviated PPT. This is when a solid is going to form. Sometimes you'll combine 2 liquids and then a solid forms and sinks to the bottom. That's the precipitant. When physical or chemical changes occur, energy is always involved. The energy can take several different forms, such as light or heat. Accounting for all the energy present before and after a change is not a simple process. Scientists have been able to do this through experimentation. The total energy in a change remains the same. The energy can be absorbed. Remember, if it's absorbed, it's endothermic, or released, which would be an exothermic. It is not destroyed and it's not created. This is known as the law of conservation of energy. Again, it'll be in a different form, but the total amounts will still be the same. An introduction to the periodic table. You know, when you look at the periodic table, you're going to see a bunch of different elements represented. It's kind of the alphabet of chemistry. We have a set of elements that you are responsible for knowing the name and symbol. Spelling will count. I will give you a handout for the elements that you are responsible for knowing. Some basic information for the periodic table. Families or groups. These are the elements that are in a vertical column on the periodic table, and there are a total of 18 different groups or families. The periods are the horizontal elements on the periodic table. There are 7 of them, plus the lanthanide and actinide series. The metals you will find on the left side of the red zigzag line. Then you have your nonmetals to the right of the red zigzag line. And then your metalloids are the elements that fall on that zigzag line. Your solids are solid black on the periodic table. Gases are going to be represented as red or green. Your liquids are represented as a solid blue color. And then the elements that aren't colored in, they kind of look like a coloring book page. Those are the ones that have not been found in nature. Okay, taking a look at 2 different styles of periodic tables. There are many others. This just kind of give you an idea. On this periodic table, the one that's in black and white, you'll notice at the top of each group or family, remember our groups or families are vertical columns that go down. You'll notice that here you've got number 2, 3, 4, all the way to number 18. And I said there are 18 groups or families on the periodic table. You might be asked to find an element on the periodic table and then give another element in the same group or family. For instance, if I asked you to find sodium. Here's sodium. Sodium is in group 1. And then you're asked to list another element on the periodic table that's found in the same group or family. You could list hydrogen, lithium, potassium, rubidium, cesium, or francinium. Those are all in the same group or family. Then you have 7 periods, which are horizontal. Hydrogen begins period 1, lithium begins period 2, sodium begins period 3, potassium begins period 4, rubidium period 5, cesium period 6, and francinium period 7. Remember, your periods go across horizontally, and you could be asked, okay, find iron. On the periodic table, here's iron, and then you're asked to find another element within the same period as iron. That could be any one of these elements to either side of iron, because those all fall within period 4. You might also be asked to find, let's say, an element in group 15. So then you would have to find group 15. Here's group 15. I'll put a little box around it. And then let's say group 15 and then period 3. Well, period 3, keep losing my pen. Sorry. Period 3, what element would that fall at? Well, you would move across the period, move down the group or family, and that lands right here at phosphorus, indicating that group 15, period 3, you would have element for phosphorus. On your notes, I ask you to tell me what element would you find in group 18, period 5. So if you guys will take a quick second, group 18, period 5. Here's group 18. Here's period 5. So if we move across all the way to group 18, that's going to land at xenon. Then in your notes, we talk about that red zigzag line. Some periodic tables have it, some don't, but typically if you're reading in a textbook, they'll say that your metals were to the left of the zigzag, nonmetals to the right. So our zigzag line would fall, kind of bear with me as I'm going to try and make it dark to distinguish for you. It's kind of like a staircase. That's the red zigzag line that they're referring to, or the little red staircase. So our metals would be everything to the left. Our nonmetals, let me go ahead and put metals here. Our nonmetals are everything to the right. And then along that staircase, you're going to find your metalloids. And if we look at this periodic table over here in color, you can see where our boron, silicon, germanium, arsenic, antimony, beryllium, and molybdenum in this neon green boxes, that represents our metalloids. On your periodic table, if you want to kind of shade in the metalloids, you could put a highlighter, you could put a dot in each box and then a key on your paper, just some way to indicate which ones are representing the metalloids. And then again, to the left are the metals and to the right are the nonmetals. We also have our lanthanide and actinide series at the bottom. And when you look at the periodic table, here's our lanthanide and our actinide series. And then see these dotted lines. Lanthanide series actually is going to come up here. Actinide series is actually going to come up here. When we talk about periodic trends, we'll go into that in more detail. Now, you need to know the properties for metals, nonmetals, and metalloids. I will read through them, but you will need to pause the video so that you have a chance to jot these down in your notes. Your metals tend to be shiny with a metallic luster. Your metals are usually silver or a grayish white, except gold tends to be yellow and copper has a reddish brown color. Your metals can conduct electricity and transfer energy. At room temperature, most of the metals are solids. Metals are malleable, meaning they can be hammered or rolled into a sheet. Metals are ductile, meaning they can be drawn into a thin, fine wire. Metals have a high tensile strength, meaning they have the ability to resist breaking when pulled. Metals in group 1 are soft enough to be cut with a knife, yet chromium is extremely hard. Nonmetals, many are gases at room temperature. Solid nonmetals tend to be brittle. Your nonmetals have a low conductivity, poor conductors of heat and electricity. Your metalloids, it's an element that has some characteristics of metals and some characteristics of nonmetals. They are solid at room temperature. They tend to be less malleable than metals, but not as brittle as your nonmetals. Your metalloids are semiconductors of electricity, meaning it's intermediate between that of a metal and a nonmetal. Your metalloids consist of boron, silicon, germanium, arsenic, antimony, beryllium, palladium. Palladium is sometimes recognized as a metal, but for our class we need to include it with the metalloids.